The vector dot product takes in two vectors and outputs a scalar number. Okay. So where did this formula come from? The dot product simply means that we are multiplying the magnitude of A, which is this part, and we learned that in the last video, and we're multiplying that by this part, which is a little bit more complex. It's the component, okay, the component of B in the direction of A. So essentially, we're multiplying this A magnitude here, okay, with this component of B projected on A. Now remember, this is just a right triangle. Okay, to help you visualize this, we can use simple trigonometry where cosine theta is equal to the adjacent side over the hypotenuse. Now the adjacent side is what we're interested in. We're multiplying the adjacent side with the magnitude of A, right? And so we can simply bring the hypotenuse over to the other side, and we know that the hypotenuse is just the magnitude of this B vector here. Cosine theta is equal to this adjacent side, which is what we want to multiply it with. And that's where the second term of the dot product comes from. And that's how you can intuitively kind of understand dot product. Mathematically, the actual dot product is this second line here, which is the x components of both vectors multiplied with each other. Then you sum that with the y components of both vectors multiplied with each other, and so on and so forth. Now that we established these relationships in terms of dot product, we can see how powerful these relationships actually are. So for example, here, we don't know, let's say, we don't know the angle between both vectors, A and B, but we know how to take the x component, the y component of both vectors, and we know how to take the magnitude of both vectors. Then we can isolate this theta algebraically, and we can just take the cosine inverse of the dot product over the magnitude of A multiplied by magnitude of B in order to get our angle theta. So that's how powerful this dot product formula is. And now we're going to do an example to solidify understanding. If, for example, the question asks you, what's the angle between these two vectors A and B here? We can try it out using our dot product relationships. So first we can take the actual dot product, which is this part here. So we want the x component of both vectors, that's 2 and 1. So the dot product of A and B is equal to 2 times 1. Remember, this is the x component of both vectors, plus the y component of both vectors, and that's 3 times 4. This becomes 2 plus 12, which is just 14. Now we also want to take these quantities here, which is the magnitude of A. So the magnitude of A is just equal to the square root of 2 squared plus 3 squared, which is the square root of 13. And the magnitude of B, okay, is equal to the square root of 1 squared plus 4 squared, which are these ones, is equal to the root of 17. Now we have everything we need, and we can plug it in to our dot product formula. Now this is all the information we need, and we know again that our theta is simply equal to the cosine inverse of the dot product of A and B over the magnitude of A times the magnitude of B. Again, if you're confused on where this came from, just go back earlier. We talked about how this is the relationship of dot product, and we simply isolated theta algebraically. Okay? So now we fill in the blanks. It's theta is equal to the cosine inverse of A dot B is 14, which we solved earlier here, over the magnitude of A, which is root 13, multiplied by root 17, which is the magnitude of B. So we plug this into a calculator and we get 0.343 radians. That should show you how powerful the dot product is for vectors. Hopefully now you kind of understand how dot product works and why it's useful.